Hi guys, so in this video I'm going to be covering assembly techniques and commands, and I'm going to be using an example that we've done previously in class. So we'll jump straight into it. The universal joint assembly is the one that we're going to be covering in this video, and to start with we're going to create one sub-assembly of the crank sub that you see here, which will consist of the knob, the arm and the crankshaft. We will then create the main assembly here, and we will use this sub-assembly and add it to our main assembly. So let's just jump straight in. So I have Solidworks open here. I'm going to click on New, click on Assembly and click OK. And you'll see that it has popped open a dialog box here on the left hand side. So to begin the assembly, as it's saying here, I need to first add my first component. So to add my first one, I click on Browse here on the left hand side, and I navigate to wherever the folder of the parts that I want to use in the assembly. So for me it's already in it, and this is the first part that I'm going to be adding to this assembly. This is the crank arm. So you'll see the arm is here, and to drop my first component, I don't just drop it anywhere in here. I come across to the left hand side and I click the green tick, which is OK. Now what that does is it places the first, apologies for the pop-ups, what that does is it places the first part and it aligns it with the planes, the origin planes of the assembly itself. So that's my first part dropped. A couple of things to note here. You'll see that this first part has a little F in brackets beside it, which means that that part itself is fixed. So if I left click and hold on this part, I can't drag and move it anywhere. So it's fixed in the space of the assembly. That's what we're looking for every time we drop our first part, and what we will be doing with any subsequent parts that we drop, we will be constraining them and adding mates to restrict their movement in relation to the first part or any previous parts that have been dropped, to remove their degrees of freedom. So I'll come along now and I'll come up to the top and I go to Insert Components. Click on that, and again I need to browse to wherever my components are. So the second part I'm going to drop is part number 8. Click on OK, and for this second part I can just drop it anywhere I want here on the screen. So I'm just going to drop it there. Again, these pop-ups are coming up because parts have been created in the educational version. You may have the same yourself. So second part is dropped. If I click on that, you'll see that it's free to move. So that can move anywhere within the space of the assembly. I need to remove those degrees of freedom. So in order to do that, I need to add a mate. So up to the top again and click on the paperclip and click on mate. So you'll see here that unfortunately I have left a face selected before I come into mate, so I do need to delete that from this selected regions. And now I'm free to pick what surfaces I want again. So the surfaces I want to mate is, I want to align the center axis of this, so I click on this face here, with the center axis of this hole, and you'll see it moves to align. Now, important things to note is that Solidworks is quite intuitive, and it will make an assumption on what mate you want to apply. So there's different mate types: parallel, perpendicular, tangent. Concentric is what I'm looking for in this case. So I can click OK, but always check before you click OK and apply the mate. Next thing I need to do is click on this top face and click on the underside of this face here, and that'll lock it to that. And coincident is the mate I want for this, because I want both of those planes or both of those faces to be coincident, to be locked together, and I click OK to that. So that's that part finished, and its degrees of freedom has been removed. Next part I want to add, click on Insert Components, down along here to Browse, and click on part 9. And this is the crankshaft. So I drop this again. I can drop this anywhere in space. Apologies for the pop-ups. So you'll see that this can still move. It's free to rotate. I need to do something. I need to do similar as to what I did with the knob with this crankshaft. So I click on mate again. I click on this outside face here of the shaft, and this inside cylindrical face of the crank arm. Important things to note are, don't select edges or points where you can avoid it. We want to select axes or faces where we can, because it removes more degrees of freedom than what selecting points or lines would. Double checking again that it's concentric. It's exactly what I'm looking for, so I click OK to that. I want to align this face here with this face here. This is applied the coincident mate, which is what I wanted. Click OK to that, and then finally I'll select this face and this top face. Again, this is what I was looking for, so I click OK here. So that's the first sub-assembly completed. So you'll see that these parts, none of these parts can move. So I'll save that, click on save, rebuild and save the document, and I'm going to call this assembly 1, assembly 2 actually, for reasons that will become clear later, and click save to that. So that's saved. I can close that. I'll just minimize that out of my way and come up and start on new. So I'm clicking on new assembly and click OK again. So just to pop back to the drawing, in all cases when you're starting an assembly, you'd start with the main component, which would tend to be the largest components in a lot of cases. So for this sub-assembly here, we started with the crank arm. For this main assembly here, we're going to start with the bracket. So, and then we'll build our part, or we'll build our assembly up around it. So it'll be the bracket, yoke male, yoke female, and then so on and so forth. So back into SolidWorks. Now, just to notice here, you'll see that Open Documents tab, because I've left that previous crank assembly open, it's still active if I wanted to drop it. Now, I don't want to drop it just yet, so instead of doing that, I come in here and I click on Browse, and I go to Part 1, and I click Open to that. And I'm going to just make sure that you've just Part 1 selected, don't have the assembly selected. Just to reiterate, don't just drop it anywhere here. Be sure and click OK, so that that first part is aligned with the origin planes of the assembly itself. So that's my first part dropped. Again, you'll notice a little F in brackets, which means it's fixed. So I can continue to add some more components. Insert components, browse, and the next part I want to add is part number 2. Drop part number 2 in here. So I'm adding my mates again to remove its degrees of freedom. So in this case, I'm going to click on mate, this cylindrical face of the part, and this inside face of the bracket. Don't click the edge, click on the face where possible. Concentric, just double checking my mate, so concentric is what I was looking for, and I can click OK to that to add it. Now, the next thing I want to add is I want to add a constraint or a mate to this top face of the part I just dropped to the underneath of this face. Now, I can't click on that face yet because it's hidden inside in the bracket itself. If I want to get access to it, just left click on the part and you'll see that I can move it. Now, be careful when you're doing that, because if I had left clicked and released, it would have selected the face, but when you left click and hold, it doesn't. So I'm just going to delete that out of there, and you'll see there, this is left clicking and holding, it doesn't select the face. Click on that top face, underneath of this, double check on my mate, which is coincident is what I want, and click add finish. And that's both mates. I don't need any more mates for now on that part. Click OK, up to your insert components again, browse, and part number 3. So part number 3 is the spider. For this I can just drop it anywhere at all. Again, apologies for the bipping and the errors. Click on mate, and now I want to align the center axis of this part, so the axis coming through here this direction, with this axis coming through the previous part. So I click on that center, that inside face, and I click on this face here, and that has aligned the axis of both of those. Now I'm going to go in to a different mate. So these are standard mates we've been applying up until now. This is a selection of standard mates. For this next one, I want to apply an advanced mate. So what I'm looking to do in this case is, I'm just going to move this roughly into the center of it for now. Bit off center. What I want to do is, when we're modeling, we will be modeling in for the ideal scenario, which means that I want to have this part directly in the center of this gap, this width we'll call it for now, in here. In order to do that, I apply width mate. What that does is, if there is, say for instance this edge was 20 and the gap was 25, if I apply a width mate, it will leave 2.5 of a gap on the left hand side and 2.5 of a gap on the right hand side. So it keeps it symmetric really. But don't use the symmetric constraint, use the width. So we click on width, and the first thing it's looking for is width selection. So for that I'm going to select my outer edges. So I select this face here and this face here of my first part, of the larger part. Next I want to select the tabs. So for the tabs I want to select this face here and this face here, and you'll see that that has moved such that it's perfectly central to the gap itself, and click OK. And that's all the mates that I need to apply to that part for now. So this is free to move. It still has 1 degree of freedom, but we'll look at that now in the next couple of parts. So insert component, browse, part number 4. Part number 4 is the long pin. So I'll drop that anywhere. Errors. Click on mate, click on the cylindrical face of this part, and center this cylindrical face here as well. So that's aligning it concentric, exactly what I'm looking for. Next I want to align this face with this face, and I want them to come in flush like that. Just to highlight another command here that it might have popped up for some of you, sometimes it will anti-align or misalign the parts. So this is aligned and anti-aligned. You'll see here that this has the pin outside of the part, which isn't what I'm looking for. In order to flip that direction, I just click on aligned. So if you think it's completely opposite to what you want, try this button here, this mate alignment. So that's what I'm looking for there. Click apply, click OK again to that. Next component, browse, part number 5, which is yoke female. So just dropping that here, and the first mate I'm going to apply is mate, cylindrical face, and cylindrical face here. So that's aligning those. Click OK to that. Next mate I'm going to apply is the same as what I did with the yoke male. So I want to apply the advanced mates here, and I want to use this width. So select this face here, this face here. So that's the 2 tabs for the larger part selected. Next I want to select the 2 tabs on the spider, so selecting this face here and the opposite face on it, this one here. So that has aligned those and kept any gap that might be in the width of it, and it's kept it symmetric. Next I want to rotate this down, and I want to have this face parallel with this face. And unfortunately I left on the width constraint, so I just need to click cancel to that and just start up again. So click on mate, click this face here, and click on this face here, and that's applied my parallel relation here, which is what I was looking for. If I needed to change it for any reason, you can click on it there. So click OK to that, and that's that guy dropped in. Next component is part 6. So browse, part 6 is the short pin. So click OK to that. Before I drop this part, if you come up here to the top and see this keep visible, this pin, if I click on that before I drop a part, it allows me to drop multiple parts. So I can click on this, drop one of them, it'll leave it active for me to drop a second one, which because I need 2 of these pins. So I'm going to drop a second one, click OK, and then click OK to that. So similar to the long pin, we need 2 relations on this, or 2 mates, and click on mate, cylindrical face here, cylindrical face here. It's the first one on. Then I'm going to select that end face of the pin here and this end face here. Now you'll notice again that that has applied it to the wrong, it's applied it in the wrong direction, so I just come here and select aligned and it brings it across for me. Click OK to that. That's that one finished, so I'll click on mate again, cylindrical face here, cylindrical face here, that is that aligned, and then I want to click on this face and click on this face. Again, wrong side there, click on the aligned rather than the anti-aligned and click OK to that. Now, before I drop in the top, that sub-assembly from previously, any of these mates that I've applied, you'll see they go into a folder here at the bottom. So it gives me a selection of whatever mates I've applied. It also tells me the type of mate it is and between which parts. So this is a concentric mate between part 1 and part 2, and it highlights it here on the right hand side. I can also check the mates of each individual part by coming in here. So if I click on this little plus beside the part and come down to mates and assembly 2, assembly 2 is the assembly I'm working in at the moment because I haven't saved it as anything else, and it tells me what mates have been applied to this part. So if I did need to delete them or edit them, it's an easier way to find them here by going into the individual parts if I know which part has the mate or constraint that I need to delete or edit. So that's where they're found. You click on the plus on any part and the top folder there should be mates and assembly, and that'll give me a selection of what mates are applied. Final step for this is to add the crank handle assembly. So I go to insert components and now I can just click it from my open documents. If it wasn't there, I just click on browse and select it from here. So assembly, that's the one I'm looking for, and I'm just going to drop that anywhere. So time to add the mates to this guy. So I want this cylindrical face here, and I want it to be aligned with this face here. So that has added my concentric mate. Click OK to that. Now the faces I need to align next are hidden to me, so left click and hold and I can drag it up out of the way and then release, double checking that you haven't actually selected the face here. If you have, so if I had clicked that and I hadn't left clicked and held, then I just need to come across here and delete it from that. So what I want to align now next is this face here, and I want to make a coincident with this guy here. So you'll see that has made a slight rotation. Coincident constraint is going to be applied, and I click OK. And finally I made this face here to this face here. Now say for instance with that one you didn't want it directly flush off that top face, you wanted to leave it up slightly so that the shaft wasn't rubbing off the bracket itself. If that is the case, you'll see that it's applying the coincident constraint, but I can add a distance here. So if I select distance, I can set that to 0.5 of a millimeter and just left click in here to activate it, and then you'll see that that has left 0.5 of a millimeter of a gap between those two surfaces, and that's that applied there. So if everything is working correctly, then this should be free to spin and rotate. Okay, so that's it for this video. I hope you found it useful, and there will be a follow-up video to this which will cover creating an assembly drawing of this assembly. Okay, thanks very much for watching, and I'll speak to you soon.